We're going to discuss optimizing the function 1 over x on the interval 0 to 3. We do have one closed endpoint at 3, but at 0 we have an open endpoint. So we lose the guarantee of having an absolute max and an absolute min, but we still need to check. So let's take a look at what's going on. So here's our graph, and we see that it's not continuous at x equals 0. Hence we could not include that endpoint. So we'll only focus on this part of the graph from 0 to infinity. Now we see that there is no absolute maximum because this graph just continues to grow without bound as we get closer and closer to 0. We have a vertical asymptote there. But if we put in a point at 3 where we had a closed interval, we do have an absolute minimum because it was a closed interval. In fact, our absolute minimum occurs at 3 and has a value of 1/3. So 3 would be the location. The value would be 1/3 of our absolute minimum. So we saw that we had no absolute maximum, and we did have an absolute minimum that was at its endpoint. In fact, the absolute minimum value was 1/3. It occurred at a location of x equals 3. Now what if the interval is 0 to infinity? Now we have an open interval. Again, we lose that guarantee. If we go back and look at the graph, well, there's still no absolute max because we have the vertical asymptote at 0. But now, there's no absolute minimum either because this graph will continue to decrease and get closer and closer to 0 as the inputs go to infinity.